In the previous two lectures, we have seen the requirements to understand what exactly assembly language is. Now, in this lecture, we will see the representation of assembly language statements into equivalent machine language statements. So, we are seeing one whole program of assembly language which is converted into machine language program. So, I, Professor Deepak Posti, welcome you for this lecture. So, this is the only one slide that I am going to explain in this lecture. So let us see the assembly language program first. Start 101. So it is the statement which is giving the starting address for the execution of this program. So start 101. The first line is read n. So n is symbol which is read by the read statement. Next is move r, move to register. What is to be moved? Content of sim operand 1 is to be moved to B register. Then move to memory, B register content to term. Now content of 1 is now available in term. Now again is a symbol which is a label, again is a label which is optional. Now here again is given mult is nothing but multiplication of B register comma term. So term into term is done here. So multiplication is performed. Then move r C raised to comma term. Now whatever is calculation done for the term, that will be taken into C register. Now addition of C register and 1 is done. What is 1? You already know the content of 1. Then next is move M C register comma term. Then move to memory. Whatever the content of C register is to read term. Then comp C register to N. Next is branch on condition less than equal to comma again. So branch on condition means if it is less than equal to, then go to the again. Next is move M B register comma result. Next is print result. Next is stop. Next is n symbol. Declare storage 1. Result is a declare storage 1. 1 is a declare constant 1. Term is declare storage 1. And at the end the program. So don't try to understand the meaning of assembly language statement. But now you need to convert this assembly language program into machine language. So let us start. Start 101 means the first instructions address is going to be 101. 101. Now, next is read state. What is the output for read? Read is add nothing but 09. Sorry. Yes, read is nothing but 09. Next is there is no register for read and print. So by default, the number is represented as 0. Then what is n? N at this stage we don't know. For time being, forgot this 113. This is empty. Okay, this is empty. In pass 1, we will go to the next step again. Next line is move r B register 1. Now after 101, the next instruction address is automatically calculated, that is 102. Now what is move r? Move r is nothing but 04. We have seen in the table of the previous lecture. So 04 indicates move r. Next is B register. Now we know we can use A register, B register, C register, D register. A register nothing but 1, B register nothing but 2, C register nothing but 3, and D register nothing but 4. So B register, for that we are writing here 2. Next, after comma, we have 1. But right now we don't know the address of 1. So just forget about this for time being. Next statement, 103, move M. So move M is nothing but 05. B register is nothing but 2 and term. Now again we don't know the address of term, so just for time being forget about this address. Next is again is a label, so just neglect that while considering the assembly machine code. Next is mult is nothing but 03. So this is by default next address 104. 03, nothing but mult. B register, you know the value for B register is 2. Term we don't know. So forget about this for time being. Next is move R. By default instruction number 105 for the next instruction. Move R we know now. Move R is nothing but 04. Now C register is used. So C register is nothing but third register. So 3. And after that term is there. So we don't know the address of term. For time being, keep this empty. Next is 106 instruction. At 106 instruction, addition is done. So addition opcode is 01. C register means 3, and we don't know the 1 address of 1. So for time being, keep this empty. Go to the next instruction, move M. By default 107th instruction, move M is nothing but 5. C register nothing but 3. Now we don't know this term, so address of term is unknown. Next is comp, complementary. Comp is nothing but 6. By default instruction number 108. C, this C is nothing but 3. This N symbol, whatever encountered here, N is again, we don't know the address of N. So keep this blank. Next is branch on condition. At instruction number 109, BC is nothing but 07. Branch on condition, this is LE. Now, just remember, we have seen a sequence of 1 to 6 like less than LT 1, LE less than equal to 2, equal to 3, GT greater than 4, greater than equal to 5, not equal to 6. So for LE, LE is nothing but 2. Again is a symbol whose address is unknown to me right now. Sorry. Again's address is known to us. Where is again? Again was encountered here. What is the address of again? Address of again is 104. So here 104 is written. Next, by default instruction number 110. Move M. Move M is nothing but 05. B registered, second register, that's why 2. Result. We don't know the address of result. So for time being, forget the address of result. Next is print. Instruction number 111. Print is nothing but 10. Result. Result is nothing but, again, we don't know the value of result. But before that, read and print are just eliminating register part. So elimination of register part is nothing but 0. Now result. Result's address is unknown. So for that, forget this address for time being. Next is stop. At instruction 112, stop means all 0. Keep in mind. After that, next address is 113. Now, which symbol is encountered first here? First we encountered with N. So NDS1 is a declaration statement. So N with DS1 means declare storage of 1 for N. So 113 is nothing but address of N now. 113 is nothing but address of N. Now next instruction address is 114. Result DS1. Result declare storage 1 means give 1 space to the result. So results address is 114. 1 DC1. So declare constant. Value of constant is 1. Value of constant, name of constant is 1. So 1's address is 115. Next is term, declare storage 1. So declare storage 1 for term. So term's address is 116. For declare storage, there is no any machine language statement, but for declare constant, there is a statement with 0, 0, 0 and the value of that constant. Value of constant is 1. And at the end statement is there. For the end, there is no any statement number. I hope you got this situation of the code. Now, the only part remaining is the addresses of the symbols, whatever we ignored in the pass 1. So this is called as pass 1. I repeat, this is called as pass 1. I repeat, this is called as pass 1. After pass 1, in second pass, we know the values of each and every symbol. So these are just put here. Whatever is blank over there, the values of addresses of each and every symbol is given here. So you can see now the statement 101 read 09 register is 0 n. Now what is mean by n? N is nothing but check the address of n as 113. So machine instruction for read n is 101 plus 09 0113. Next is what is remaining? Address of 1 is remaining. So what is the address of 1? 1's address is, you can check here, 1's address is 115. So here 115 is given. Next is term. What is the address of term? 116. What is the address of term? 116. What is the address of term? 116. What is the address of 1? 1. Check it out. 115. What is the address of term? 116. What is the address of n? 113. What is the address of again? Already calculated again 104, which is kept here. What is the address of result? The address of result is 114. What is the address of result? 114. What is the address of result? 114. Now you can see this is the complete machine code for the given assembly language program. Now whatever is calculated, whatever the variant, whatever the addresses of each symbols are given in the this output is nothing but pass 2. So I repeated, this is called as pass 1, this is called as pass 1. Now whatever I explained after pass 1 is nothing but pass 2. Now, what is done in pass 2? In pass 2, by considering symbol table, we have just given the values for each and every neglected symbol places. I hope you understood this. I'll clear each drawing here. So this is nothing but conversion of simple assembly language program into machine language program. Concluding remark, thus we have seen how a machine language program is generated from an assembly language program. Slide credit goes to Professor D.M. Namdere. Happy learning. Do subscribe the channel to get the notifications of new videos.